Okay, so everybody can see my screen?
Yes.
Okay, perfect. All right, so my name is Isaiah Stapleton. Today I'm going to be talking about the work I did this summer on as a part of my summer 2022 internship with Red Hat on the Unikernel Linux project. So what are we going to be actually talking about today? First, I'm going to talk a little bit about myself. Then I'm going to give you some necessary background information for understanding the project. Then I'm going to talk about the project itself, the main task I was given for this project, why this work I'm doing actually matters, my current progress with this work. Then I will talk about a side task I was given that's related to my main task, however, it slightly differs. Then I would go into some problems and solutions I ran into with both my main task and my side task, some next steps following for the Unikernel Linux project, some related work I did throughout my internship, things I learned throughout my internship, and then that should conclude the presentation and we can go into a Q&A. So a brief introduction about me. Like I said, my name is Isaiah Stapleton. I was born in Dover, New Hampshire, and I moved to Charleston, South Carolina around 12 years ago. Currently going into my senior year at the College of Charleston, majoring in computer science and minoring in data science. Outside of my interest in computer science, I'm very passionate about linguistics, more specifically language and language acquisition. Because of this, I'm currently conducting a one-year research project where I'm designing a mobile language learning application utilizing comprehensible input. Basically, a more natural way to learn a language as opposed to the more traditional method of drilling vocab and grammar. So now I'm going to talk about some background information. So to understand the Unikernel Linux project, it's important to understand what a unikernel actually is itself. So what is a unikernel? A unikernel is essentially a highly specialized operating system that's designed to run a single privilege application that's linked with a kernel and executes in a single address space. It only contains application code as well as all necessary operating system functions required by that application. So in short, it's essentially just a highly specialized operating system designed to run one single application. So when I tell people this, they sometimes get a little bit confused about what the difference between a unikernel and a container is. So I thought it would help to take a look at the architecture between the two to compare. So if you take a look at the architecture for a unikernel, each unikernel actually has its own kernel with the library and the application code being built directly in, whereas containers have a shared kernel with the library and the application code being separate. So what's the point of a unikernel? What problem are they actually aiming to solve? Well, oftentimes virtual machines are used to run only a single application belonging to a single user. This gives us the opportunity to run a trimmed down kernel, which does not need to support a lot of the things which traditional kernels support. For example, there's no need to support isolation between different users, no need to support thousands of drivers, and no need to support isolation between different processes. The benefits of this are very fast boot times, increased performance, as well as increased security due to the decrease in the attack surface for the application. So now that you have some of the background information, you understand what a unikernel is. What is the Unikernel Linux project? The Unikernel Linux project is essentially a small patch to Linux and glibc, which allows one to build many programs as unikernels. It's not aimed to actually turn the Linux kernel into a unikernel itself, but rather offer a system for applying unikernel optimization techniques to the Linux kernel. The current goals of the project are to offer a selection of these applications optimized using these unikernel techniques and working towards the upstream submission of the UKL patch set. So why did I choose to work on this project? Well, I chose to work on this project because I believe that the goal of optimizing these applications using unikernel optimization techniques and then getting these changes pushed upstream to the Linux community would have a huge positive impact on the Linux community, and I would like to help bring that change. So what was I actually tasked with for the Unikernel Linux project? My main task I was given is support Nginx over to the Unikernel Linux project and perform benchmark testing in order to compare the results to the Lupine benchmark tests. All you need to know about Nginx is that it is a very popular open source web server. Lupine is a highly specialized operating system that employs similar unikernel optimization techniques as the Unikernel Linux project. We're comparing against Lupine because they're one of the most recent specialized operating systems that employ these unikernel optimization techniques, and their performance is better than other state-of-the-art techniques at the moment. So why does this work actually matter? Why is it important to port Nginx over to the Unikernel Linux project? Well, in order to get our changes to the Linux kernel pushed upstream, we have to show that our changes to these applications can make a significant difference in their performance. And so by porting Nginx over to the Unikernel Linux project and then performing benchmark testing on its performance, showing its performance increase, that pushes us one step closer to getting these changes pushed upstream to the Linux community. So where am I with the current progress of this task? Well, first I had to build the Nginx from source. Then I had to figure out which dependencies it has and their dependencies all the way back to glibc. And then I had to make sure we can build the entire dependency tree in Nginx in a UKL compatible way. After I did this, I had to actually build Nginx in a UKL compatible way and then get it to boot as a UKL kernel. The most recent task which I completed is to perform benchmark tests on UKL Nginx. And so here you can see the preliminary results for the benchmark test. This is just one single benchmark test used for comparison between UKL and Lupine. On the left, you can see a benchmark test for UKL Nginx, and on the right, you can see a benchmark test for Lupine Nginx. As you can see, there was a large improvement in application performance for UKL Nginx over Lupine Nginx. There was a 39% increase in requests per second, a 28% decrease in time per request, and a 39% increase in the transfer rate. Now, these preliminary results must be taken with a grain of salt because Lupine Nginx was run on their hardware under their network conditions, whereas UKL Nginx was run on my hardware under my network conditions. The UKL team is currently trying to get Lupine to run on our own hardware so I can then perform my own benchmark testing on Lupine Nginx in order to give a more accurate comparison on the performance increases for UKL Nginx. Thus far, we've had some issues getting Lupine to run on our own hardware. However, we currently have an individual on the UKL team working on this problem. In the meantime, while they work on that problem, I was given a side task. The side task that I was given was to implement TCP shortcuts in order to improve the performance of Nginx. Essentially, there's a TCP code path for send and receive in the Linux kernel, and the first few functions in this code basically check conditions and flags to find which function to call for send and receive because there are different options available. However, since we already know which path it must take, we are able to bypass all those checks and go directly to the necessary function. This gives us a performance boost because the code now does not have to waste time making a decision for which path to take every single time we send and receive. So my current progress with the side task, I was able to implement the send shortcut. However, I've had issues getting the receive shortcut to be implemented, and I will talk about those issues that I ran into in a second. So now I want to talk about some problems and solutions I ran into for both my main task and my side task. So for my main task, when I was able to actually get UKL to build when I was able to get Nginx to build in a UKL compatible way, and I tried to get it to boot, I ran into this error where open dev null failed, no such file or directory. The cause of this was the dev directory not populating when building UKL Nginx. Essentially, when a UKL application boots, an init script is run and it creates the dev directory, but it's empty because Superman builds the root system out of RPM contents, which don't include the dev directory. On a real system, the dev directory is populated using systemd-udev. However, in UKL, we do not use systemd-udev, and so the dev directory does not populate correctly. And so this dev null is required for Nginx to actually run. And so the solution to this was one that Richard Jones actually had to implement. He added changes to the Unikernel Linux project to change the way that applications are actually built so that the directories were populating correctly. And so now the dev directory, after implementing the solution, the dev directory was populating correctly and Nginx was able to boot. So now I have it booted, however, it's not performing correctly. It's not performing as it should. And when it ran, you could see that Nginx was listening on port 80. However, when I tried to run the benchmark test, nothing was happening. And so when looking into it further and checking the error logs for Nginx, I found this error, socket pair failed while spawning worker process. The root cause of this was essentially a function in the Linux kernel called putUser that writes values from kernel space into user space. If this destination was found to be outside of user space, the process would essentially fail. And so we're working with unikernels. We're going to be working in kernel space. We are not going to be in user space. And so that destination was always kernel space. It was never user space. And so the process was failing. So the solution to this was to modify the Linux kernel to bypass this check. And so that we can now properly write values from kernel space into kernel space, and it was not failing the process because it wasn't in user space. So once that solution was implemented, I was able to actually get Nginx to run, after which I performed those benchmark tests. And so now on my side task, the first issue that I ran into was this undefined reference to the shortcut TCP function that we implemented. The root cause of this was Nginx failing to build, causing the entire build process to halt. So in the Nginx code, I basically had to tell it that this shortcut TCP send function is somewhere else in the build, somewhere else that you're not going to see until the build and linking process is done. However, it wasn't, when Nginx was trying to build, it wasn't seeing this function, causing Nginx failing to build, which caused the entire build process to halt. The solution to this was to edit the Nginx makefile to ignore this failure to build in order to continue the build process. The reason this solution works is because now Nginx is not seeing this function and it's failing, but the build process continues. And then at the end of the build and linking process, Nginx can now see that this function, they can now properly see this function in order to implement it. So once this solution was implemented, I was able to get the send shortcut implemented and working. However, when trying to implement the receive shortcut, I ran into kernel panic during benchmark testing. It was seemingly random. I would perform the benchmark testing, and sometimes it would work. However, sometimes it would lead to kernel panic. The current root cause of this is not known, and as such, there's no solution. But it seems to be something with the UKL build itself and not Nginx. That is just one problem that we're going to have to look into further. So what are my next steps? Well, I need to get so we still need to get Lupine benchmark tests running on the same hardware, after which we can compare UKL Nginx benchmark tests to the Lupine Nginx benchmark tests in order to offer a more accurate comparison for the performance increases for UKL Nginx over Lupine Nginx. After this is done, I'm going to work to further optimize UKL Nginx. So a part of my next steps, there's some tools I need to learn. Cscope is essentially a tool for tracing C source code, and GDB is used to basically see what's going on inside a program while it's running. And so these two tools are kind of invaluable for kernel development, because I'm not sure if any of you have tried to debug C code, but it is not very easy. And these two tools allow you to debug with much greater ease. And so these are going to be two tools that I really need to learn in order to work further in kernel development. I also need to learn Vim, which is just a text editor. However, it is a very powerful text editor. Throughout the internship, I was using the Nano text editor, and because that's what I was familiar with. However, it's very slow to use. It's not as powerful as Vim, and when making edits, it's just very slow. And so I was kind of hesitant to use Vim at first because it has a very steep learning curve, which would kind of slow me down at first. However, I know in the long run, learning Vim is going to be invaluable, as it will really speed up my process. So some related work I did the Linux kernel development workshop, which was actually put together by our fellow intern, Jonathan Cameron. This workshop was really like a great dive into Linux kernel development. I had no previous experience with kernel development, and this kind of just gave me the basics that I needed to kind of get my foot into kernel development. I also started reading Linux Kernel Development 3rd Edition by Robert Love, very similar to the Linux Kernel Development Workshop. However, it goes a lot more into depth. And so I placed the links to both. The second one, it's a free PDF to the book. So if any of you are interested in kernel development, feel free to check these out. I really recommend the workshop for those that have never worked with Linux kernel development before. So some things I have learned throughout my internship. First and foremost, I learned a lot about kernel development. I learned a lot about kernel development because this was the first project I was on dealing with kernel development. And as such, I kind of just had to learn quickly and pick things up. And so I learned a lot about kernel development throughout my internship this summer. I also learned a lot about open source development, not only from just my project itself being open source, but also from all the other interns who have been working on open source projects, talking about what they have learned in open source and about the open source development. I learned a lot about Git as well. So Git was a tool that I was familiar with before. However, I was only really familiar with using it with maybe like 1 or 2 other people for a class project. And I never really ran into many issues with it just because there wasn't many people pushing changes and pulling changes. It was just like something that like sometimes they would send me all the code and I would just push it. And so it was really easy to use when working with very few people. However, in a real project like this, you often have many developers, or you have many contributors. And so I was often running into issues with Git that would take me hours to fix. And because of this, I learned a lot about Git, which I'm very grateful for, as it's going to be a tool that is going to be invaluable for my time here at Red Hat in the future. I also improved upon my presentation skills a lot, largely in part due to the Build community, Build being the Blacks United in Leadership and Diversity. The Build community had the interns basically present 3 or 4 presentations throughout the summer, throughout our internship. with the build leadership team there giving us feedback on our presentation and our presentation skills. Because of the feedback that I received from the build leadership, I feel a lot more confident in presenting, and I feel as my presentation skills improved a lot. But not just build, I also presented to Eric Munson, my technical mentor. I presented to Shamir Bison, my early talent mentor. I presented to my family and friends. All of these people gave me feedback on my presentation skills, which really helped me to improve my presentation skills. I also learned how and when to ask for help. At the beginning of my internship, I didn't really know when to ask for help. I kind of would be stuck on a problem and didn't really want to ask for help because I didn't want to seem maybe stupid. I didn't want to seem like I didn't know what I was doing. And so I didn't really know when to ask for help. And when I needed to ask for help, I didn't really know how was best to ask for help. And so this is something that I worked on with my early talent mentor, Shamir Bison, a lot. And now at the end of my internship, I now feel very confident in how to ask for help and also when to ask for help. I don't now spend unnecessary time on a task when I could just ask for help. I also learned how to fight imposter syndrome. This was something that I worked on a lot with my mentor. At the beginning of my internship, was experiencing a lot of imposter syndrome. I felt as if I knew basically nothing. But what really helped me was to realize that I'm an intern. I'm not here to know everything. I'm here to learn. And so me being willing to learn and put in the work, that's all that matters. And so now anytime I'm really experiencing imposter syndrome, I just remember I'm here to learn. This problem that I'm facing doesn't devalue me and my skills. I can learn from this, and I will learn from it, and that's what I'm here to do. And so, yeah, these are the things that I learned throughout my internship, or the more important things that I learned throughout my internship. And that about concludes my presentation. I want to give special thanks to my technical mentors, Eric Munson and Larry Woodman, my early talent mentor, Shamir Bison, my manager, Heidi Dempsey, Ali Raza, Richard Jones, and the rest of the UKL research team. So now if anybody has any questions, feel free to ask. I'd also love if you guys connected with me on LinkedIn, if you had any further questions or you would just like to talk about anything. But thank you guys. And yeah, feel free to ask any questions. Yes, so
first, Emacs, not BIM. Second, yeah, no, you could have spent your life imposter syndrome. You always feel that because the field expands so much. All of us don't know anything but some aspect of it. Maybe it's at a high level, if you have an overview, or maybe it's a detail, but you're always learning. That's what life's about. So it's a really good thing to learn now. The other thing is, just a technical question, the hardware so you got the same experiment running on Lupine, but on their hardware, not on our hardware. Is that correct?
The Lupine, those experiments, like that benchmark test that I showed, that was run on their hardware. So they have their repository with all the benchmark tests open and available. And so I just
is that stuff that was just recently rerun, or
no? That's what I was trying to say, is that those were old benchmark tests.
Okay.
And so that was what they initially. Those were the benchmark tests that they initially ran, and then the UKL Nginx benchmark tests that I ran were very recent. And that's why.
What is the difference in generation and time of their hardware versus the hardware you were running on?
I believe. Sorry, I do not have the exact year, but I believe that it was a few years ago, something around like 2018 was when.
Sorry, I think you're misunderstanding. Let me just state concretely: their hardware is much newer than the hardware we ran it on. So the improved performance. So I think you can expect that your results understate the advantage rather than overstate them with the UKL approach.
I see the thing. Yeah, their hardware is completely different than mine. And yeah, if they're granted that their hardware is right or better than ours, then those important improvements in the performance of Nginx would be greater.
Nice job.
I was wondering where we can see this work. Is it available somewhere or repository?
Yeah. So I will. There on the intern project spreadsheet with all of our intern projects, there's a link to the repository for the Unikernel Linux project, and then on that repository, there's a branch called Add Nginx, and those are where the changes that I made for adding Nginx to the Unikernel Linux project are. It's my hope that they're going to be pushed into the main branch soon, but right now that's where you can view those changes that I've made.
Yeah, fantastic. Very interesting work. Thanks for sharing. Nice presentation.
Thank you.
Yeah, really interesting work and a great presentation too. And I have to say that I was imagining a soap opera in my mind as you were going through. This worked, and then this failed, and then this worked, and then this failed. But it's really important to tell people the whole story and what you go through, so that they don't have the impression at the end that you came in, you knew everything, and you just got it to work, because nobody's internship goes that way. So
Right.
Thanks for including all that.
Yeah, of course. Yeah, that's why I also felt it was important to talk about imposter syndrome, as I feel like that's something that every single intern probably faced, and I didn't really hear many people talk about it, so I thought it would help others.
Yep.
But yeah, that was basically it. Does anybody else have any other further questions?
Yeah, Isaiah, I think you did a great job. I really enjoyed working with you the past few months. You had shared a couple different types of software you need to learn how to use. Do you have a plan in place for how you implement that and how you're going to balance that with your schoolwork this coming August? Which one you're going to attack first and next? You have
Yeah, so basically I want to first start with so this working on C, that's going to kind of improving my C programming skills is going to kind of go hand in hand with my coursework in the fall. I'm going to be doing upper level computer science courses where I'm hopefully going to be utilizing C. And even if I don't utilize C, it's still going to improve my development skills in general. As for Vim, I'm just going to kind of have to jump into using the Vim text editor in place of Nano. And maybe at first it will slow me down, but over time it will lead to like tremendous gains in my performance or my efficiency in working. And so I kind of want to tackle those two first, C and Vim, after which those C-scope and GDB. Emacs, maybe I'll look into it. But after which I will look into improving or learning C-scope and GDB, as those are going to be tools that are going to be invaluable for kernel development. However, I'm going to focus on Vim and C first, because C, scope, and GDB is going to be kind of a bigger undertaking. Learning those is going to take a lot more time.
awesome. I'm glad you already have that planned out.
Yeah, I second Duran's comment about GDB mode in Emacs too. Even though Emacs is ancient, GDB mode is really cool.
All right. Well, if nobody else has any questions, I'm going to end the recording, and that about concludes my final presentation. Thank you, everybody, for coming today.
Sorry, I didn't unmute fast enough. Just wanted to say, awesome work. That was really, it's a complicated thing when there's all these different layers, and it's not surprising what you ran into, and you showed the perseverance to get to bash your head bloody against the problems and actually get things solved. So really impressed with what you accomplished.
Thank you.
Eric, you're muted. You're still muted. You're still muted.
But he's
maybe
saying
it's the microphone. Like, it's not on Google Meet. Maybe it's something hardware switch.
maybe he's running a Unikernel video. He's saying how awesome Isaiah is, I'm sure.
Could have been criticisms. Okay.